Today we're going to talk about core data more. Specifically, we're really going to focus on two things. We're going to talk about migration, which means making changes to your core data data model, and then allowing a new version of your app to open and migrate old data stored with an older version of the app. We're going to go into a little more depth on fetch request. Specifically, we're going to talk about how to use predicates to narrow down the objects that you fetch. And really, we're doing that partly in support of learning about a class called NSFetchedResultsController, which is a class that is specifically designed to help you hook up a table view to core data. Let's start, though, by talking about migration. So this is actually a scenario that comes up no matter what kind of persistence system you're using, where you release version 1.0 of your app. It has a data model. And by that, we just mean a format for the data, a collection of classes for model objects, and each has properties, and maybe they have relationships between them. And your app gets popular, and there's some new feature that you want to add that requires you to change the data you're storing, either add new properties, add additional model classes, maybe change properties, in some cases even delete properties. Lots of different reasons you might want to change the format of data that your app stores. The problem is if you release that update and the new version of your app doesn't know how to open old data and convert it, you have a problem because all of your existing users can't access their old data. The way we solve that is with migration. So migration just refers to converting data in an older format to data that matches the new format. This is actually a relatively tricky problem. It's not something that's just, trivial for any given set of changes. Luckily, core data gives us some tools to make migration easier. And there are basically core data support for migration is quite sophisticated. There's quite a lot of power there. But there are basically three levels or three kinds of migration. We're going to focus on the first one, which is also the easiest and simplest and also the most commonly used, and that's lightweight migration. We'll get into the details of lightweight migration a lot more in just a minute. But there are two other levels. If lightweight migration won't work for you, meaning that the changes to your data model are a little more complex than lightweight migration can handle, you can step up to using a mapping model. A mapping model is not too much harder than lightweight migration, but it's considerably more powerful. It does require you to do some work to tell core data how to convert from the old version to the new version. But it's not, you generally don't have to write code for that. You just create what's called a mapping model file that is actually sort of like a data model file, except that it tells how to go from the old entities to the new entities and so on, new old attributes to new attributes, etc. And it allows you to specify some rules and even to, if you want to, write a little bit of code in the mapping model that will do various kinds of transformations. If a mapping model is still not enough, if you need to do something that's even more complicated than what a mapping model can handle, you can do fully custom migration. So fully custom migration means you basically take over the migration process, write code that does whatever you want it to do in terms of migration. And of course, this means that you really can do pretty much anything. You're not limited by core data's idea of what constitutes changes between two versions of your data model. It does require you to write code, of course. It's not just a file that you create. And the good news is, even if you're doing a fully custom migration, core data gives you tools, basically a context within which to do that. So it still does some of the hard work for you, and you can kind of customize as little or as much as you need to. That was not always true. When core data first shipped, when I first started using it, it didn't have any built-in support for migration. There was some content in the documentation that told you how to do a migration, gave you some idea of how to do a migration, but there was no API for it. There was no core data knowledge or support for it directly. You just had to do everything yourself. And I can tell you that, and having written that kind of migration code, I can tell you that even a fully custom migration in modern core data is significantly easier than when you had to do it all yourself. With all that out of the way, we're going to talk about lightweight migration today. And the reason we're doing this is partly because it's the easiest, and obviously we don't want to dump the hardest thing on you. but also because lightweight migration is the most common kind of migration you'll do. It's sufficient for most kinds of changes you might make to your data. And so, it gets you 90% of the way there. There are some rules for when lightweight migration can be used. Basically, there are a list of requirements for the changes to your data, and if the changes you're making are more complicated than those rules allow, you can't use lightweight migration. You have to step up to a mapping model. So let's go through the requirements for lightweight migration. This is on Training Kit, so you're welcome to look this up and follow along, and you have a reference there. It's also, of course, in the documentation somewhere. I'd have to find the link. Oh, well, that's weird. There we go. So the rules are right here. And basically the changes that are allowed with lightweight migration are adding new optional attributes. So any entity in your core data model, if you need to add a new attribute to it, you can add an attribute as long as it's optional. And that makes sense because if you've got data, existing instances of that entity in your existing saved data files, your existing persistent stores, and you add a new attribute and it's not optional, well, core data needs to know what to put in there. So, but if it's optional, well, it'll just be nil. You can also add non-optional attributes as long as you specify a default value. We didn't really cover this yesterday, but the data model editor actually lets you specify default values for any attribute. As long as you provide a default value, you can add a non-optional attribute. Again, that makes sense because then core data knows what to put in for that attribute when it migrates entities from older data stores that don't have data for that attribute. You can remove an attribute. And of course, if you do this, any data that is stored in that attribute in the existing store just gets deleted. So be aware of that. You do lose data if you do that. But if you're removing the attribute, presumably that's because you don't need or care about that data anymore. You can change an attribute from non-optional to optional, and you can also change an optional attribute to non-optional as long as you, again, provide a default value. And if you think about it, those both make sense. You can understand how core data could just figure out what to do in those cases. You can also rename an entity, an attribute, or a relationship. So renaming works. There are some limits to this. If you rename an entity and you also rename all of its attributes and you add a bunch of attributes and you delete some attributes and basically completely change it, well, core data is not going to be able to figure out what you did. Lightweight mapping or lightweight migration requires core data to infer, in other words, to figure out how to convert from the old format to the new format. And it can figure out a lot, but it's not going to be able to read your mind if you make some really major changes. And in that case, you would have to step up to a mapping model. And then the last thing you can do is add a new relationship or delete an existing relationship. And again, this is, a relationship is really a special case of a property. A relationship is just one entity with a attribute that points to one or more instances of another entity in core data. And so if you think about it, this is really just an extension of all of the changes that you can make to attributes. There are a few other kind of esoteric changes that lightweight migration can support, but you're very unlikely to encounter them. If you care, you can find them in the documentation. Okay, before we move on, I want to hear if anyone has any questions about the rules for lightweight migration or the 3 different kinds of migration that core data does.
I actually have a question about the mapping model.
Sure.
Is that a graphical thing that you can do?
Yes, it is. Yep. In fact, if we get time, I'll briefly show you how it works. It is a graphical thing. It's very similar to the editor that you use to edit it is very similar to the data model editor. It's powerful, but yes, it is graphical. You don't write code for it. Any other questions? All right. So the next question is, okay, well, how do I do this? How do I make lightweight migration work? The good news is if you're using NS persistent container, which we have been, you don't need to do anything. Lightweight migration is just enabled for you. And the first time your app runs with a new model format, older data will automatically be migrated to the new format. If you're not using NS persistent container, if you're using kind of the old way of doing things, you can enable lightweight migration by setting 2 options in basically a dictionary that you send when you create or load the persistent store. Look up the documentation if you need to do that, but really you should just be using NS persistent container. So we are going to work on our tasks app from yesterday. If you have a good copy that you finished yesterday and got working, you should use that. For those that don't, for one reason or another, have a good copy to start with, I am going to post my version on Slack so that you can download it and start from a good, consistent starting point. Let me do that right now. Okay, there it is in the iOS3 Slack channel. And then I will open that. All right. So how do we add, what we're going to do is we're going to add a priority attribute to our task. Right now, task just has name and notes, and we want to be able to assign a priority like low, medium, or high. Actually, we're going to do low, normal, high, or critical. First of all, we already have this data model. You do not just add a new thing to this data model, and the reason for that is because core data does need a copy of the old data model so that it can open data in the old format before converting it to the new format. Instead, we add a new version of our data model. And the way you do that is to select the data model, open it like I've got here, and then go up to the editor menu and select add model version. You'll get a screen that looks like this. You can name your new version. You can name it whatever you want. It's just tasks 2 by default. And then you say which model version you want this version to be based on. Of course, we've only got one existing version, so you can only choose one thing there. And then you just hit finish, and that's it. And you notice that there's been a change here. Now there's an arrow next to your data model, and if you're really paying attention, you might, well, no, I think it was data model D before, but anyway, there's an arrow next to tasks.xt data model, and you can actually expand this now, and there are 2 different data models. You also notice there's a green check mark next to this one. That means that this is the current data model. This is the one that the app would use if we ran now, and in fact, it would just ignore this one because it doesn't have a green check mark. So the green check mark means this is the currently active data model. We want to actually make this the active data model. And so the way you do that is to open up the file inspector, and you'll notice that this is the file inspector with the little page. You'll notice that down, most of the way down, there's a section that says model version, and the current one is tasks. We'll just change that to tasks 2. And you'll notice the green check mark moves. That means that now if we run the app, it will use the task 2 XC data model.
I'm sorry, Andrew. I'm going to ask you just to say that one more time. I got mixed up with my computer.
Yep, sure. So you understand the green check mark? You just want to see how to change it? Is that what we're talking about?
Yeah, I need to change it to task 2.
Okay. So to change the current version of the data model, one that's the change which data model is being used, you select either one. It doesn't actually matter. And then under the file inspector, which is the one with the little folded page, about most of the way down, there's a section for model version, and it says current version, and you just pick the version that you want. So task 2 here.
No, I'm sorry. How did you make task 2? I was in the middle.
Oh, okay. So you select your data model, and then you go to editor, add model version.
I'm good now.
Okay. So now we have 2 versions of our data model. We have our old version that we were using before. We have our new version that we're going to use for this app going forward. And we can make whatever changes we want to make to this task 2 version of the data model. Now remember, if we're going to use lightweight migration, we need to follow the rules. we want to add a priority attribute. If you think back to the rules that I put on screen and went through, one of the allowable changes was the addition of an attribute that is optional or a non-optional attribute with a default value. We're going to add priority. We'll call it priority. And we're actually going to make it a string. So it's just going to be low, normal, higher, critical. We'll use an enum in code to make that easier, but core data doesn't know about enums. So we'll make it a string. And then we're actually going to make it non-optional because we want all tasks to have a priority. If we make it non-optional under the rules of lightweight migration, we need to provide a default value. So we're going to fill in a default value under the default value text box down here. And I'm going to make the default value normal. And that's it. So we actually don't have to do anything else. If we run the app, core data will just migrate. And in fact, you can see that in your table view controller just to debug, just to see what happens. I'm gonna on view did appear. I'm just gonna go for task in tasks print task priority. That's not priority. And if this works, we expect those all to say normal, right? Because the old data is just going to have priority added, and it's going to use the default value. But if this works at all, it's because migration worked. So if I run the app, this is optional. Don't worry about it though. That warning's meaningless. I only have 2 tasks in my store, but you notice they both got normal, so it worked. I want all of you to try this. Stick this code in your view did appear. This is just temporary code, just to test that it worked. Run the app, make sure that migration worked, and the way you'll know is that if this prints out normal for everything. And if you are worried about it saying optional, you could force unwrap that and it'd be fine. If that works, raise your hand in the participants window. Okay, there's a bunch of you that still haven't raised your hand. If you have trouble, let me know. And I know probably some of you are just waiting on the simulator, which is fine.
It says type task has no member priority.
Have you actually built the project?
Yeah.
I did that in the store, man.
I can look at it. Try cleaning. If you just go to product clean build folder, sorry, or you can hit Shift Command K and then build and run again.
Oh, it built. Yeah, it worked.
Okay, good. So the issue is that the class, the actual Swift class for anything that's in your core data model is generated by Xcode when you build the project, and it sometimes can be a little flaky about regenerating it. But if you clean the build folder, it'll force it to rebuild everything. So okay, there's still like 4 of you that don't have your hands up. Oh, Jarek, I guess there's 2 of you, but you're good. Yeah.
I wasn't able to get it working yesterday, so that's why.
Oh, did you start with the version that I provided?
Yeah. Oh, I see. Yeah. Okay. I'll just do it with the version you gave.
Okay.
Thanks.
Are we okay to keep going, Latan, or do you need me to wait for you?
No, we're okay.
Okay, great. All right, so we've added priority. I want you to try something though, without breaking anything that's here. Add a third version. This is just to try it out. Add a third version, tasks 3, and then figure out a change that is not one of the ones on this list, and make it, and then run the app and see what happens. So add a third data model, set that as the current version, and then in that make some change that doesn't fall under these rules, and just see what happens when you run the app. And when you're done, raise your hand.
So it'd be based on the current task 2 rather than task, right?
Yes, exactly. It'd be based on task 2. Yep. Let's take 7 minutes for this. I think that's a reasonable amount of time.
Did anybody else's app crash on priority, just like the first one that we did?
Sorry, say that again.
I was just asking anybody. So mine actually just crashed on the first one we did, like priority, and then I made another one called "It's Completed," and that I didn't even get there. So maybe I.
Oh well, you shouldn't have raised your hand if your app was crashing before.
Well, it didn't crash, but I tried to actually use it. It ran, it succeeded, but then it actually didn't. When I tried to make a name and then a note, it didn't actually save. So I misunderstood. I'm sorry.
Okay, well, I can take a look.
Okay.
I can take a look if you want to share your screen.
Sure.
But everybody else just keep working on yours.
1 second here. Here we go. So
let's set. Well, yeah. So you've okay. So let's.
this is task 2, and now
sure.
I'm on task 3. Yep.
So on task. So this is what I want you to do. Set tasks 2 as the current version.
Okay.
It's the next one over. And then stop this app and go to your simulator. Oh, actually, yeah. Set tasks 1 as the current version.
Okay.
And then
run it.
No, just stop the app and then go to the simulator.
Got it.
And delete tasks. That way you delete the existing data and you can just start over. That's annoying.
That's why I don't like to use iPhone.
You could also just switch to a different simulator that doesn't have.
Let's do that. Trust the iPhone 7.
It just switched back to the 10 for some reason.
Oh, God.
So you actually have 2 errors. It's not going to run. Just comment out that code, right? Because yeah, that's fine. Don't worry about that.
Okay. Here we go. Name.
Yeah, so just create a task or 2. And then you can go ahead and quit the app now.
Okay. Stop it.
Yeah, sure, that's fine. And then set tasks 2 as your current one. Go back to your code in task table view controller. And uncomment the priority one. Yep. And then now run it. Try it. It'll probably still work. Yeah.
Yeah.
Oh, interesting. Okay. Validation error, missing entries. Oh, so I think you don't have the. Sorry, that's this timer. Hang on. I think you don't have a default value set in your model.
Okay.
And remember, that's one of the rules. If you add an attribute, it either has to be optional or have a default value.
So then I found that out. There we go.
So it's not optional, which is right. I want it to be not optional, but you also need to set a default value. We just did normal for the default value. Yeah. I bet it works now. Well, actually, that's interesting. Oh, yeah. Okay. Yes, but I bet it works. No.
Okay.
It's because the last migration failed, but you fixed it. You fixed the problem.
Okay.
So
I guess that was what you wanted to show us. Okay.
Yeah, I mean that was basically the.
Okay. Sorry.
Okay. So what happened?
So basically, I didn't follow the rules. I didn't have a value, and I tried to do that with the new one. It's completed. Try to set it as a Boolean, but didn't set it as a true or false. But I guess my priority was it actually wasn't set.
Yeah, you had already tried that. What about the rest of you? What happened? Well, only one of you has. 2 of you have your hands up, so I guess you didn't get there. But
I named my new attribute break, and it said I'm not allowed to do that.
You made it called break?
Yeah.
And what did it say?
I need to
Okay.
use the backticks and stuff.
Yeah, because break is a keyword.
Yeah.
Yeah,
so
okay.
Mine just crashed the second I launched it because I gave it an attribute. Where'd it go? I gave it a non-optional attribute. Yeah, and it didn't. I mean, the previous tasks in there no longer have it. So
Right. So you give it an optional attribute, it crashes, but let's think about why it's actually crashing. It's crashing because load persistent stores fails and returns an error, and we fatal errored on that.
yeah.
So that's actually what happens is load persistent stores fails and you get an error. And the error, if you read this message that gets printed out, it'll tell you in detail why it failed. But I just wanted you to see that. If you violate the rules of lightweight migration, loading persistent stores fails. We're not going to use the third one that you added. So select it. If you I'll do it too, so I can show you. That's good. So select it here and just hit delete. Or actually, I guess you can't do that.
Do we need to change it back to one of the other tasks first?
Yeah, so change it back to 2 as your current version, but I don't know why I can't delete this. I thought I could. That's interesting. Well, it won't hurt anything to just leave it in there, but it's kind of strange. I thought I had done that before. It's a bit of a, you can do it, but it's a bit of a process. Just don't worry about it. Just set your current version back to tasks 2. And then the other thing you want to do is go into your simulator and delete the tasks app so that you delete, any garbage data that's in there now. All right. Okay. So if you've done that, we should be good to go. The app should work again. Now that we've got priority in there, we need to add to we're going to use priority for some other things today. So we're going to add to our initializer, we're going to add a parameter for priority, but instead of just having it take a string, we're going to use an enum. So I'm going to come into my task plus convenience and create an enum called task priority, and I'll make its raw value a string. That means that way we can store it in core data, because core data, that attribute, the priority attribute, is a string, and core data doesn't know about enums. So we'll add low, normal, high, and critical cases. Do I do something like that? And then we're just going to add a third parameter here that is priority of type task priority, and we'll give it a default value of normal so you don't have to specify it. And then in here, we'll just say self.priority equals priority.raw value. So take the string value of whatever was passed in and set the underlying property. We might want to add a convenience or a computed property that returns an enum instead of a string for task. But it turns out that for the code we're going to write today, we don't actually need that. So I'm not going to. So just having the initializer take one is enough for now. Okay. And then the next thing we're going to do is go into our storyboard and add a way to change the priority. So what I'm going to do is add a stack view. And specifically, I'm going to add a horizontal stack view right here between name and where the notes field goes. And there's, of course, nothing in it, but it'll show up in the right place over here. And then I'm going to add a label to that stack view. You'll see the label. And then I'm also going to add a segmented control. The segmented control I'm going to stick right here, right to the right of the label, like that. So go ahead and set this up. Horizontal stack view, under the stack view for name and its text field, it has a label, which, by the way, we're going to make priority, and a segmented control. And then that stack view should be fill, and the spacing should be standard, not 0.
Andrew, what does standard spacing mean?
Standard spacing means whatever spacing like Apple's guidelines specify. So I don't know. It depends on context, and I think it's 20, maybe 16 points here. But the idea is that way you don't have to think about like what the best spacing is, and you can just be consistent and use standard spacing. And that means like let Apple decide what a good spacing is. And it could theoretically change between versions of the operating system or whatever. I don't know if it ever has, but it could. Does that make sense?
Yeah, definitely. Thanks.
So select the segmented control, and it says in the attributes inspector, you'll see that it says segments 2. And we actually want it to have 4 segments for each of our priorities. So change that to 4. And then just make them low, medium, high, and critical.
I think medium should be normal.
Sorry, you're right. Well, it doesn't actually matter, but sure, normal is fine.
Okay.
Yeah, we're not. Yes, you're right. It wouldn't affect our code, but yes, let's do that. Okay, and then we just need to add an outlet to that, to our detail view controller. So from our detail view controller. So the outlet, we'll just call it priority control. That's it. Okay, if you've done that, if you haven't done that, speak up, and if you're stuck or something, let me know. But if you've done that, we've actually done everything we need to do in our storyboard for now. So we're going to switch back to code, and in our detail view controller, we just need to add support for this to our code. So the first thing we're going to do, one thing I forgot is come back to your task plus convenience.swift, and we need to be able to get all of these in an array. And luckily, there's it's actually a new thing in Swift 4.2, which of course just came out a few weeks ago, where if you make your enum conform to the case iterable protocol, it will get a magic property called all cases that will just be an array of each of the possible enum values. So go in and just add conformance to case iterable. And I'll link to the documentation for that just in case you want to read more, because I know it's a little bit of a quick aside and we haven't really talked about it. It's a cool new feature in Swift 4.2. Not that you guys care, because Swift 4.2 is the only real. Well, I guess you guys were using. Maybe were you using Swift 4.1 when you first started? I can't remember. But to me, it's really nice because we had to do this code. We had to write code for that ourselves before, which was not hard, but a little bit of a pain. Okay, having done that, we can switch back to our detail view controller. And we need to know which priority was selected. So the easiest way to do that is just to say priority index is our priority controls selected segment index. So this will be 0 through 3. And then to get the priority that corresponds to that, we'll say task priority dot all cases. So this is an array of all of the possible values of task priority. And by the way, they will be in the same order as they appear in the enum definition. So they'll go low, normal, high, critical, which is what we want. So we'll just do all cases sub priority index, and this will give us the priority that was selected. And having done that, we can just set that wherever we were setting other things. So set it here. Sorry, this will be priority.raw value because we have to set a string. And then this one will be priority when we create one. And that's it. That's all we have to do and save. We also need to change our update views, but we'll do that in just a sec. So add this, set the priority, and you'll have to use the raw value to turn the priority into a string. And then when we create a new task, provide the priority argument. All right. So we also need to change our update views to show the task priority. And to do that, we're just going to say I'm going to create a constant called priority. And then we're going to set it. Sorry, we actually don't need that part. We're going to say priority is dot priority. If that's nil, oh no, now I remember why I did it this way. I did it a different way in the code, in my solution, and I didn't remember why, but now I know. There's another way to do this, but yeah, we'll do it this way. If we have a task priority, and remember this would fail if we didn't have a task, if task was nil, meaning we're creating a new priority and we want to select normal by default. So if it's not nil, then priority is our task priority converted from a string, which this is, right? This is a string, converted back into a task priority enum value. Otherwise, we'll just set priority to normal. And then we will say priority control dot selected segment index equals task priority all cases index of priority, and we'll force unwrap this because it can't fail. Actually, we got to force unwrap that too. Just add that. This is a bit of code, and I'm concerned that there are people who don't fully grasp what we just did here or why we did it exactly this way. So who has questions?
The last part, the task priority all cases index, that I don't understand.
Okay. So all cases is just an array of all of the cases of task priority, and they are in the same order as these. So it'll just be low, normal, high, critical in an array. We want to find out which index, which segment index in the priority control should be the selected one. If you look at the priority control, it just has 4 segments, and these have an index 0, 1, 2, 3, and that's how we, if we want to tell the priority control to select one of these, to make one of these the selected or highlighted one, we have to tell it which index should be selected. So we need some way to convert from a task priority, an enum priority, task priority enum, to a number 0 through 3 that is the corresponding index for the segment in the priority control. And the way we do that is we say, okay, well, here's an array of all the cases, all of the possible values for task priority. We want the index of this priority in that array. So if this was low, we'd get 0. If this was high, we'd get 2. If it's critical, we'd get 3, and so on. And therefore select the right index. Does that make sense?
Yes, it's instead of case 1, case 0, to do this.
Yeah, we could do it with a switch
case. Yeah.
Right. Yep.
And it goes in the order we listed the priorities?
Yes, whatever you have listed in your enum, all cases will be in the same order.
Okay.
All right, so if you got that, it should all work. You should be able to create a task, give it a priority, and probably try something other than normal since that's the default. Save it. If you go back to it, you should see the priority selected. You should be able to stop and run the app again, and it should still be there, and you should be able to change it as well. And if you change it, it should stay changed. So please test that, and then raise your hand if it works.
Andrew, I'm getting all types of errors today. I'm on the short bus today.
It's okay. What's going on?
Let me share my screen because I feel like I got everything, but something's happening here. I feel like I didn't just declare something properly somewhere.
That looks okay. Are you actually building, or are those live errors?
Those are live. I'm not getting. I'm not getting.
Oh, it's because you have priority equals task priority, and it should be priority colon. We're just saying the type is task priority.
Okay.
And then you just need to force unwrap that. Because the raw value initializer on an enum can always fail. Gotcha. No, sorry, force unwrap the result of the initializer there. Because what if you just passed in Bob? Well, there is no task priority for that, so it would return nil. But we know that our task priority will be one of the valid.
Gotcha. Oh, jeez. All right. Typos. Thank
Okay. Who has their hand up? Please remember to raise your hand if you've got it working. And if you don't have it working and need help, please tell me so I can help.
So what's interesting with mine is that it's saving as normal, and then when I go back in, it saves it back to high or whatever it needs to do.
So explain that again. Yeah, say it a different way because I didn't get that exactly.
Yeah. So like if I make like a task, right, it saves it, and then at the initialization of the task, if I want it to be like critical task, it'll save it to normal first, and then when I go back into the task, it goes.
Oh, right. Okay.
Yeah.
So if you think about it, there are two different paths for setting priority. It could be because you're editing an existing task. Sounds like that part's working. Could be because you're creating a new task. It sounds like that part's not working. So you need to make sure the code in both branches of this if statement is right.
Got it.
Does that make sense?
Yes.
Mine crashes when I try to change the priority.
Okay. What does the crash say?
It's a SIGBART error.
But in the console, what do you see? Probably unexpectedly found nil while unwrapping optional value. That's my guess. But I could be wrong.
Unrecognized selector sent to instance. And
What is the unrecognized selector?
I think is it the NS invalid argument exception or task detail view controller priority control 1 unrecognized selector sent to instance.
Let's have you share your screen. I'm pushing you a little because being able to read error messages like that is actually really important, and it's something students struggle with at first. They want to overlook things they shouldn't overlook and not overlook things that they should. Can you maybe make that bigger so we have more space to see it? Maybe close your sidebar. All right, terminating app due to uncaught exception and NS invalid argument exception. So it is the type of the exception is NS invalid argument exception. Reason, task detail view controller priority control, unrecognized selector sent to instance. So it is saying you called the priority control method on an instance of tasks.taskDetail view controller, which is just task.detail view controller. And that number is actually the specific instance that it was called on. Really what this is telling you is that there's some code that called priority control on a task detail view controller, but task detail view controller doesn't have a priority control method. I'd have to look at your code to see any more than that. Priority control, segment index. Scroll all the way down to the bottom, or wherever you put your priority control, UI segmented control. Looks fine. Okay, so what I'm going to have you do is go into your breakpoint navigator, which is the second to the last tab in the left sidebar. In the left sidebar, second to last tab at the top. That's the breakpoint navigator. Click the plus button down in the bottom left corner, and then choose exception breakpoint. You'll learn about this in like 2 weeks. You'll have a whole lesson on it. And then choose for exception where it says all. Choose Objective-C, Objective-C, and then that's fine. That's enough right there. So go ahead and run the app again. This will make the app stop when that error occurs instead of just crashing. It'll make it stop in the debugger, and we can figure out exactly what line it's happening on. Okay, there we go. Oh, that's interesting. Over on the left, over on the very bottom of the left sidebar, there's a thing that looks like a sort of like a sideways TIE fighter kind of thing. Yeah, click that. Oh, it's an action that's getting sent. Oh, okay. I know what's going on. Yeah, I know what's going on. Go back into your storyboard. And right click on the priority control. And you'll have an action in there. Value changed. The problem is you accidentally created an action instead of an outlet, and then you didn't delete it. So just delete that. Did that work, Sean? You're muted, but
Yeah, it worked. It's just weird because I did that initially because I accidentally made the action at first.
yeah.
And I got like something, I can't remember what the error said, something 5. So I undid the deletion. So.
Oh, well, yeah, I don't know exactly, but all right. So it sounds like though we're all in good shape. So let's take a 5-minute break, and then we'll come back, and we're going to learn about predicates. It's changing gears a little, but we're going to come back to this priority thing that we just added. So see you in 5 minutes. Sorry I'm late, but I'm back. If you're back, turn your camera on, please. I see you, Lotana. I mean, I see a silhouette.
Yeah, sorry. It's just like the window behind me is lighter, so it's, it's like light issues.
Yeah,
that's why I like put my hand up.
I can see that you're here, so that's what I care about. All right, so we're gonna talk about NSPredicate. NSPredicate is kind of a cool class. It's not specific to core data, although we're going to use it for core data. Core data does use it, but other things use it too in iOS. And fundamentally, what NSPredicate is, it's a way for you to define a test. So I'm going to show you the documentation. Let me share my screen. What do I mean by define a test? Well, if you've got an array of objects, or you've got a fetch request for core data, or maybe even a query on a web service, you often want to say, I only want objects that match these criteria. Maybe for our task app, we might want to implement a search feature where the user could select a priority and only show items with that priority. Or maybe we'd have a search field and they could type in some text and we would want to find only tasks with that word in either their name or their notes. Those would be tests that we would want objects to pass to be included in the results. So we'd say, this test is, does this object have this word somewhere in its name property? Or another example would be, the test is, is this object's priority property critical, for example. NSPredicate is a class that lets you define the criteria for a test like that. We call that a predicate. So you can do simple comparisons like grade. So imagine this is like a school app that keeps track of students. Grade equals 7. You only want students in 7th grade. Or first name, like, I don't know how you say that, but Shafik or something like that. And it's got some features that are pretty nice, including case and diacritic insensitivity, which we're not going to cover in much detail. But case insensitive means that you don't care if things are uppercase or lowercase. Diacritic insensitive means that you don't care if, for example, if a word like cafe could be spelled C-A-F-E, or it could be spelled C-A-F-E with the little, I don't know what you call that thing, the little on top, like the actual French way to spell it. That's accent. Called accent. Yeah.
Hey, Andrew. Sorry. Yes. Could you please explain more about diacritic insensitive, because my first language has a lot of diacritics like under the words.
Oh, sure.
So that might be something relevant for me later on.
Yeah. What is your first language?
It's Igbo, I-G-B-O. I believe like the Unicode sign is I-G.
Okay. So I don't actually know. I don't know about that language specifically, but diacritic insensitive means, like, for example, the example I was giving is cafe could be spelled in American English. It's usually spelled just C-A-F-E with no accent on the E.
Yeah.
But in French, you'd have an accent on the E. If you put in cafe with no diacritic, but you wanted it to match the version with the diacritic, you would select diacritic insensitivity. It basically just ignores diacritics on any letter. It considers the version with a diacritic the same as the version without. If there are letters that could have multiple diacritics, so I'm trying to think.
Yeah, so we have multiple diacritics. So for example, because we have the language is tonal, we have to have accent markers on top of the letter to show whether it's a high tone or a low tone.
Right.
But then also, because the language has short and long vowels, we also have to have a dot underneath the same letter to show whether it's a short vowel or a long vowel. So you have the letter E, for example. The short E has a dot underneath it, and it also has an accent on top if it's going to be like a high tone or low tone. So it has multiple diacritics.
Interesting. So I don't want to give you 100% definite answer because I, to be honest, I have never dived into this deeply. I speak English. I speak English and Japanese, and Japanese doesn't have diacritic. Well,
I speak English, French, Igbo, Hausa, and a little bit of Spanish.
So I think you should just play with this. I think you should come up with a test you can do. But I think what will happen is that the letter will match without any diacritics at all, or any combination of diacritics.
Okay.
I think that's what will happen. Note that diacritic insensitivity is an option. So if you want to be diacritic sensitive, you can. In fact, that's the default. Okay. What you see here is the brackets after contain. So this is a predicate that says the name property on each object must contain the string itron, however you say that. The brackets after the contains are options for that contains, and C means case insensitive, D means diacritic insensitive. If you left the D off, you would get diacritic sensitivity, meaning only things with the same diacritics would match. Okay. Does that make sense?
Mm-hmm. Yes.
I would play around. I mean, I'd be interested to hear how that works with a language that's, because I think most Americans' first thought is just like French or German, where there are diacritics, but they're not super complicated. And
our diacritic system is like pretty complicated just because it's both a tonal language and it's a language where the difference between the length of the vowels changes the meaning entirely.
Right.
So like my name Lotana means like remember your father, but then if you say my name as Lotana, it means remember to eat your father.
Yeah, that's it sounds to me like it's one of those languages that if you don't speak a language like that, it's super hard.
Yeah.
Anyway, I'd like to hear what you find out if you want to play around with that. So predicates can be pretty sophisticated. For example, you could have a date between two dates. You could test for that. You can go down through properties. So you could say if an object has a group property and then group is another object that has a name property, you can kind of drill down through multiple levels. You can even use key value coding collection operators to say that, for example, if you have an object that has an array of items and each item has a price, you only want objects where the sum of all of its items price is less than 1,000. So you can do pretty sophisticated stuff. You can also combine predicates using or and and. There's a whole page here. It's more than one page. A whole document here about programming with predicates. One thing you will see a lot now, this is just as of the last few months, is a lot of the documentation says this document is no longer being updated for the latest information. Blah blah blah. Well, that may be true, but a lot of the documentation now says this, and that's not because it's invalid in any way at all. It's just because for some reason Apple went through all of their documentation and said this is no longer being updated if they were not like rewriting it right now, I feel like. So ignore that. Anyway, this is good information about predicates. We're not going to use anything too complicated. We're going to use pretty simple stuff. Yeah, go ahead.
Is it like queries, like select table where name is equal Jack?
Yes, exactly. So predicate, NS predicate can be used to just like filter an array, for an example. But core data uses it in the same way that SQL uses queries. So you provide.
Why is it called test then?
Well, that's just my word that I use.
Okay.
Because it's defining a test that you want objects to pass, and SQL queries are like that too, right? If you say, I want objects whose name starts with the letter A, well, that's a test that they have to pass. If this object's name doesn't start with the letter A, it's not going to be included in the result of the query. So because it didn't pass the test.
Yep.
That's just my way of describing it. Core data uses predicates where you would use queries in a database system. You create predicates with a string and an argument array. This is perhaps the thing that is weirdest to a Swift programmer, but you'll learn how to use it. We'll learn how to use it in just a second. There is documentation called the predicate format string syntax that shows you how to do this. Unfortunately, all of the example code is still in Objective-C. That's one of the reasons you're going to be learning Objective-C, is so you can kind of mentally translate this stuff. But there's a bunch of different things you can do. You can do equals, greater than, less than, between. true and false, which you don't use those very often, but and or not, begins with, contains, ends with, like, which is just really simple expression matching. You can have wildcard characters. You can also use regular expressions, et cetera, et cetera. There's lots of stuff here. If you have any experience with SQL, it has similar capabilities to a SQL query. And you do use string, just like a SQL query is a string, just text. Predicates use text. We'll see how to do that in just a second. We're going to actually use this to say that in our task controller, so what we're going to do is we're going to go into our table view controller. Sorry, in our storyboard. We're going to add a view, just a regular view. If you search for UI view, you'll find it. It's this one down at the bottom. And drag that into the table view, which is, you'll see this thing at the top and right there. And then inside that, I want to add a stack view, a horizontal stack view. Inside the horizontal stack view, I'm going to add a label. And I'm going to add a segmented control. It's hidden now. I'm going to stick it. I'll just use this. And then I'm going to constrain the stack view. So I've selected the stack view over here. I'm just going to constrain it 0 on the top, 20 on the sides, and 0 on the bottom. I'm going to set the alignment to center and the distribution to fill, and then make spacing standard. And then I'm going to make it the same as this. It's just going to be the same kind of priority control. So I'm going to, priority selector. So I'm going to have 4 segments. Low, normal. That's annoying. High. Sorry. That's annoying. Low, normal, high, and critical. That should be all you need to do. Oh, and then make this say, actually, yeah, make this say priority. And then add action to this, for this. And the action is on your table view controller. The action should be show only priority, or let's see, filter by priority. And I just realized that we should have, yeah, that's fine. Filter by priority. You can make sender be a UI segmented control if you want. Okay, if you're stuck or need help with something, let me know.
Did you give the stack view 20 points to the sides?
Yeah, 20 on the left and right, and then 0 on top and bottom. And I changed the alignment to center instead of fill.
Awesome, thank you.
I'm just waiting to make sure everyone has time to catch up. Okay. We're going to continue. So that's all we're going to do in the storyboard. We're going to say, I'm just going to add a property down here called priority. Make it private. Priority will be a task priority, and we'll set it to normal as the default value. All right, so then just in here, all we have to do is say priority index equals sender dot selected segment index, and then say priority equals sorry, my brain just kind of went blank. Task priority dot all cases sub priority index. So we'll get the priority that corresponds to that selected segment index and set our priority property. And then we're going to say in priority, we're going to add a did set so that if priority is changed, we reload our table view. Okay, so we've got all the infrastructure in place so that if the user taps on the segmented control for priority, we set this property to the appropriate corresponding priority and then reload the table view. The next thing we need to do is make it so that the tasks array only returns tasks whose priority matches what has been set here, right? So to do that, we need to use a predicate. We need to say, I only want this fetch request to return objects whose priority matches what has been set in this property. We do that by creating a predicate. And we give it a format. So the format is going to be %@. Sorry, let me make sure I get this right. No, we don't need %@ yet. We're going to say the format is going to be priority. So this is the key, the property that we're going to use in our test, equals %@. %@, this is Objective-C's string interpolation syntax. NS predicate is actually a Objective-C API, as are all of the APIs that you're using. And you'll learn about how this works in a couple sprints, but basically you use %@ where you want to substitute a value at runtime. So we want priority to be equal to whatever is in this property. Well, we can't there's no way to hard code that in a string. We say substitute here the current value of priority, and then we provide that by saying priority here. So whatever is in this list after the string will get substituted in for the %@. This is discussed in more detail in the training kit text for this objective, if you want to go read it. And then all we have to do is say fetch request dot predicate equals predicate. We just set, there's a property on fetch request, you give it a predicate, and that's all you have to do. So now if we run the app, oh, sorry, this needs to be raw value, right? So because we actually need the string to go in there. We run the app. So I've only got one task and it's critical. So you don't, that's why you're not seeing anything here. And then critical, I see something. Could fix that by adding, you know, here's a normal thing. Here's a low one. Here's a high one. Now, as I select these, you'll see them. Okay, so everybody try that out. See what happens. I'm going to make sure it works with multiple ones. Another normal one. Yep, sure enough. And then raise your hand if it works.
I'm missing some code in the filter by priority function.
Okay.
If I can get that.
This one.
There we go. Yeah. Oh, there we go. That's what it was.
Now, of course, like if you wanted to do our filter by more than one property or more than one attribute, really, we could actually do that too, right? You can be like,
yeah, absolutely,
date and last name. And,
yeah. So there's actually a couple ways to do that, but the easy way is to say like, and, you know, name contains something, I don't know, %at.
Okay.
You know, whatever, like whatever you want that to be important, or this just some random, whatever you want it to be. Could come from a text field or something. You know?
Gotcha.
And it's a string. The format is a string. So how do you debug it or see if you made an error mistake there?
You get an error. I mean, it will throw an error when you try to do the fetch request. But that's how it works. So, but you're right, of course, that if I put a typo in that, I mean, you can see what happens, right? Try it. Try putting a typo in. This is indeed a string, and if I just make that wrong, it breaks right there, and it says key path, you know, my typo version not found in entity task. This is actually a SQL error because in our use of core data, by default, it actually is using SQL in the back end. So predicates do get turned into SQL statements. But, you know, I mean, that's relatively straightforward, right? That's not a thing on the entity task. Does that make sense?
Yep.
And just to clarify, something like location, would location be like a string, like the latitude, longitude, or would it be kind of like the way that Apple does location?
So that's actually a good question. We could actually get into a pretty deep discussion of this problem, but you would probably store location as two separate numbers, latitude and longitude, right? And so if you did that, you'd have a predicate where this doesn't have to be a string, by the way. It can be a number, right? Priority happens to be a string, but if we were using a property that was a number, you'd substitute a number in here instead of a string. You could say, you know, latitude has to be this value, or latitude has to be this, and longitude has to be this. Or you could use between to say I want my latitude to be between, you know, 40 and 50, and my longitude to be between 100 and 110 or whatever.
Got it.
Define a region. So you certainly can get pretty sophisticated.
Got it.
All right. I know Jarek's good. Lotana and Moses, where are you at?
I'm good. I just forgot to raise my hand.
Okay. You guys are going to get used to that because that's how I do things. Okay, great. All right. So that's how you do a priority or to do a predicate. We're actually gonna comment this out. So I want you to comment this out because the next thing we do is not going to integrate with this super well. So just comment this code out, and then well, that's really all you need to do. I mean, you could comment this out, this code out as well, but there's no reason to. So just comment this out. This is going to mean that our priority selector doesn't work anymore, but that's okay. The next thing we're going to learn about is a class called NSFetchedResultsController. So I want to talk for a minute about, you know what, actually, I think what I'm going to do, I think I'm going to take this out, and then I'm going to send you guys this project, and let's start fresh with that stuff not in there. I know that's not like a super clean, nice way to do this, but it's just going to make it, just going to make it easier. You've seen how to do that. If you want to, save a copy of the one you've got to refer to later. Make sure this still works. Yeah, okay. All right, so okay, so there's another tasks.zip in the iOS3 Slack channel. Go ahead and download that. That way we can just all start fresh. If you want to, you could delete those out of your own, but you don't have to. Okay, so hopefully you've all got this open. Let's talk about what Fetch Results Controller does. So Fetch Results Controller really kind of has, it's kind of hard to split it up, I guess, but it has really two or three main capabilities. Fundamentally, NSFetchedResultsController is meant to make it easier to implement a good table view that is backed by core data. Usually on iOS, if you've got a table view and it's showing model data that a user can manipulate, the user can view, create, edit, and delete model objects. And the controller, which usually is a table view controller or some other kind of view controller that is responsible for the table view, combined with some sort of model controller, has the responsibility for coordinating between the table view and the underlying model data. That is model view controller, right? You've got your model data stored in core data, your view might be a table view, and then there's this controller object that coordinates between the two. When that model data is core data, Fetch Results Controller will do a lot of the hard work of your controller layer for you without you having to write code. It will help you keep your table view in sync with the underlying core data managed objects. It will basically what it does is you give it a fetch request. That's why it's Fetched Results Controller, to tell it, hey, here are the objects that I want to display in this table view. And that fetch request can be any fetch request you'd use with core data. It can have a predicate if you want it to. It doesn't have to have a predicate if you just want to fetch all objects of a certain entity. But you give it a fetch request and you say, here are the objects I want to display in this table view. And then it will take responsibility for fetching those objects, providing them to you. But more importantly, it will watch the managed object context for changes and inform you via some delegate methods that we're going to implement when changes have been made. So if a new object gets created in the managed object context, the Fetch Results Controller will see that has happened and say, hey, a new object was just added. You might want to update your table view. The same goes for if an object is edited, if an object is deleted, or if an object is moved, changes order, which happens because an object has been edited. So that's at its core, that's what Fetch Results Controller does. It watches a managed object context using a fetch request, and anytime it sees changes to the objects that are returned by that fetch request, it informs you. And it does that in an efficient way. So we talked about how this is quite inefficient because you're running a whole fetch request every time this task's property gets accessed. And what would be better is to watch to see if the objects change and then only refetch when they do. Fetch Results Controller does that. And that's why I told you yesterday, this is not really the best way to do this, but we'll learn tomorrow. The thing you were going to learn about tomorrow was, of course, Fetch Results Controller. Fetch Results Controller also does another cool thing, which is it makes it really easy to split your data into multiple sections based on the value of a specific property and keep those sections up to date as data changes. So for example, we could use separate sections in our table view to show tasks of different priorities. We could have a section for high priority, critical, high, normal, and low priority sections. And Fetch Results Controller could separate our objects into those sections for us without us having to write code to do it, which is quite nice. So we're going to switch our table view controller to use Fetch Results Controller instead of using just this kind of naive approach that we've done so far. So the first thing that we're going to do is, well, we're going to get rid of this property. We're not going to use the tasks computed property anymore. Instead, we're going to just define a Fetch Results Controller. Fetch Results Controller takes several lines of code to set up, so I'm going to make this a lazy variable. It's going to be of type Fetch Results Controller, and then we'll use the, oh, by the way, it's a Fetch Results Controller that manages tasks, so we'll specify that. And then we'll use that same syntax we saw yesterday where we set it equal to the result of calling a closure. We're going to create a fetch request. That fetch request is just like before. It's just going to be a fetch request, a task fetch request that returns all tasks. So we'll create it exactly the same way we did before. There is one difference, and that is when you use a Fetch Results Controller, you must provide sort descriptors. So we saw how to set up predicate property on a fetch request, which tells it which objects you're interested in. You can also set what are called sort descriptors, which tells the fetch request what order the returned result should be in. Fetch Results Controller uses that to figure out what order the things in your table view should be in. We didn't really we just glossed over this, but up until now, our table view has just shown tasks in whatever order the fetch request happened to return them, and we had no control over what that order was. It was just using some default order that Core Data uses. It's probably the order they were created in, but I don't even know for sure. So in this case, we're going to explicitly say we want to sort by the name key. So you create sort descriptors is an array of instances of NS sort descriptor. NS sort descriptor takes a key, and then whether you want to sort that key, sorry, I want to get autocomplete so I don't spell that wrong. And then whether you want to sort in ascending or descending order. So ascending order would mean alphabetical by name. If we passed in false here, we would get the reverse of alphabetical order. So Z would be first. So we're going to sort alphabetically by the name, but we could sort by lots of other things, right? We could sort alphabetically by notes. If we had other properties, we could sort by them. And of course, the reason this is an array, we're actually going to come back to this, but the reason this is an array is because if two tasks have the same name, then you don't know which one should come first. So you can provide an additional criteria by which to sort. So we might say, well, if two tasks have the same name, maybe we want the one with the higher priority to come first or something like that. But we're going to, for now, we're going to just sort by name. I'm assuming that stuff in chat from you, Sean, was an accident, but if not, I hope you're okay. Okay. And then, so there, we have sort descriptors. We need our managed object context. So we'll just get that from our core data stack. And now we're ready to create a fetch results controller. So I often call it FRC for fetch results controller. You initialize a fetch results controller with 4 arguments: a fetch request, a managed object context, a section name key path, and a cache name. We'll talk about each of these. The fetch request is, of course, the fetch request that tells the fetch results controller which objects you're interested in. Again, we're interested in all tasks because we didn't set a predicate. This also tells the results controller how those should be sorted. You give it a managed object context. I think that's pretty self-explanatory. This is the managed object context that it's going to execute its fetch request on. Also, it's the one it's watching for changes. Section name key path is where you provide a property that you want the fetch results controller to use to split things into sections. It's optional because maybe you don't want to split things into sections, and we're actually going to start with that, so we will leave this nil. And then cache name can be nil. I actually almost never use this, but this makes it so that the sectioning data that it creates gets cached to disk. If you had a ton of objects split into lots of sections and they did not change frequently, setting this would be a good way to improve launch performance of your app, but it actually doesn't come up that often, so setting it to nil is usually fine. And then Fetch Results Controller requires that you set a delegate. So we need to make our class here conform to the NSFetchedResultsController delegate property, or sorry, protocol. And we're going to implement the methods for this in just a minute. And then set the delegate here. So we're going to say frc.delegate equals self. This is important. After you've set your fetch results controller up, you have to tell it, hey, okay, I've set you up, start going. Start watching the managed object context and letting me know when there are changes. You do that by calling the fetch results controller.perform fetch method. Now this sounds like it's a one-time thing, but it's actually not. This should probably be named something like start, because it means start going. It doesn't stop working. It doesn't just do a one-time thing. It means, okay, start watching this context and letting me know anytime there are changes. So we'll do that. This is actually an error throwing method. We could wrap it in a do catch, but I'm just going to be lazy and do a try exclamation. And then just return FRC. Now this, by the way, this should not fail unless you've set up your fetch request wrong, like you'd included sort descriptors that this key is wrong, or you forgot to provide a managed object context or something, or I don't think you can actually do that because I don't think this is optional. But this shouldn't fail unless you've made a mistake here. And so arguably, crashing is better than trying to do something anyway, but probably could wrap it into do catch. Anyway, I'm just being lazy. So return the fetch results controller and we're done. So we've set this up. Before we move on, who has questions about this code?
We're just basically setting an observer. That's essentially.
Yeah, we're basically saying, hey, fetch results controller, I want you to observe this managed object context, and anytime there are changes, let me know. And it will let us know via some delegate methods that we're about to implement. So specifically, let's start implementing those. Specifically, there are 4 methods that you should implement. Well, really, in our case here, I think we only need 3 of those, but I'll show you. We'll start. There's controller will change content. So this just means, hey, I just noticed there was a change. I'm about to start telling you about it. And we want to batch those changes up. If multiple changes were made at the same time, we don't want our table view to keep updating over and over again. So instead, we're going to say table view.begin updates, which just starts a batch change to our table view. There's controller did change content, which means, hey, I just finished telling you about all of these changes that I noticed. So we can say, okay, our batch is done. This tells the table view to go ahead and update to show everything that has just happened. This is just a way of combining changes into one actual update to the table view, to what's shown on screen. Okay. And then the most important method is controller did change. Let's see, an object, this one. Controller did change an object at index path for type new index path. There's a lot to digest here, but fundamentally this method gets called by the fetch results controller on its delegate anytime it notices a change. So whether that's a new object was added, an object was deleted, or an object's properties were changed, this will get called. It provides the fetch results controller that noticed the change. Not super important. I mean, that's kind of obvious. The object that changed, so this would be a core data object. The index path that object was at before the change. So this is the index path in the table view. The type of the change, this is an enum, and we'll look at this in just a second, but it's basically insert, delete, update, or move. And then the new index path. So if an object was moved, this will be the new index path it should be at. If it was deleted, this will be nil, etc. We'll look at these more in just a second. So the first thing we're going to do is we're going to say, okay, I want to know, first of all, what kind of change happened. So we'll switch on the change type, and there are 4 possibilities. There's insert, delete, move, and update. We don't need a default because those are the only options. Insert means a new object was just added, was just created. It will not have an index path, which could properly be called old index path because it didn't exist before this change happened. It will have a new index path, which is the index path in the table view that it should be at. So this is optional, so we do need to unwrap it. So we'll use a guard statement. So I'll unwrap that. If it is nil, which certainly shouldn't be, we'll just return. And then we'll tell the table view, hey, you should insert a new row at this index path. And we'll just use the automatic animation. So, hey, table view, you just got a new row. Please show that. For delete, when an object is deleted, it will have an old index path because it did exist in the table view. It will not have a new index path because it's been deleted. It doesn't exist anymore. So we'll unwrap the old index path. And then we'll tell the table view, hey, please delete this row. The automatic animation. For move, we'll have both an old index path and a new index path because that's what this is saying, is that this object moved from one row to another or maybe one section to another. It moved. We do that by saying, so we need to unwrap both of them. So I'll say old index path equals index path and new index path equals new index path. Table view has a move row at to, which you would be tempted to use, but for reasons I don't want to get into in depth, that actually is problematic and won't work. It'll crash in this case. Instead, we're going to do it in 2 steps. We're going to say, hey, first delete the old index path. And then, after you've done that, insert an object at the new index path. Oh, sorry, this is new index path. Okay. The last one we need to implement is update. This update just means, hey, the thing didn't move. It wasn't inserted, deleted, or moved. It just had a property that changed. So we'll say guard let index path equals index path. This gives us which object was changed, or where the object that changed was. And then because a property just changed, all we're going to do is tell the table view to please reload that row. This tells the table view, hey, reload only this row, which is much more efficient than loading the entire table view because it will just call self-erode index path for that single row. Okay. So to recap, this makes it so that when our fetch results controller notices changes in the managed object context, it calls this method, and we use this method to update our table view. There are 4 different kinds of changes that it watches for. Inserts, meaning new objects that were created. Deletes, meaning an object was deleted. Move, which just means an object moved. And that could be from one row to another row in the same section, or it could be moving between sections if we had set up sections, which we haven't. And then update, which just means one property changed. Depending on the type of change, we do something a little different to tell the table view to update itself. The other thing we need to do is make it so that our data for our table view is no longer pulled from this tasks computed property, which we got rid of. Instead, data should always be pulled from the fetch results controller, which provides an array of result objects. So instead of returning tasks.count, we're going to return fetch results control from this. So this is table view number of rows in section. We're going to return fetch results controller dot. There's actually a couple ways to do this. I just want to see if, yeah, we're just going to use fetch results controller dot. Oh, sorry, I just had it. I have it. I did it differently in my. Sorry, just a sec. I did it differently in the solution code, which I should not do, but I sometimes do. Oh yeah, duh. It's fetched objects dot count, and if fetched objects is nil, we'll just nil coalesce that as and use 0. That way we can just use optional chaining there. So instead of maintaining our own property that does a fetch request every time we call it, we let the fetch results controller manage this array, and we just return the count of objects that it has returned. Similarly, instead of getting the task for a given cell out of our tasks property array, which we don't have anymore, we're going to say fetch results controller dot object at, and you just give it an index path, and it will return the correct object. And it even knows that this is a task. Okay, and then for deleting, same thing. Instead of getting this from our tasks property, we need to do fetch results controller dot object at index path. Build failed. Oh, that's just debug code. We don't need that. So if you still have that for loop in your view did appear, which I think you will because you started with mine, go ahead and delete it. And then there's one more place we need to do that, which is right here. In our prepare for segue, detail vc.task, again, we don't have a tasks array anymore. We got to get it from the fetch results controller using the object at index path method. So if you've done all that, your project should build. Should be able to run it. Oh, I want to show you one more thing. Sorry, before you run it, actually delete the whole view did appear method. Remember, the whole point of this was that if we created a new object and then returned back to the table view controller, the new object would not show up unless we told the table view to reload. We don't need this anymore because the fetch results controller will notice that a new object was added, and it will call this method, and we will see that change and tell our table view to update. So we don't need to just brute force reload the table view every time the view appears. So now if I create a new object, it showed up automatically. If I delete an object, it gets deleted, works fine. If I go edit an object, the only thing I'm not sure about is these don't seem to be in alphabetical order, which I did expect. If I, change that, that gets added. I think it's because of a case sensitivity. The uppercase comes before lowercase. Off the top of my head, I don't actually know how to fix that. Oh, actually, I do know how to fix that. I just realized I do know how to fix that off the top of my head. I can show you if you care. So, but test this. You should be able to add objects and have them show up automatically. You should be able to delete them and it still works. You should be able to, edit an object to have a different name and see the sort order change. And of course, it should still work if you quit the app and relaunch it to see everything. When that's working, please raise your hand.
Andrew, my simulators disappeared, I guess.
Mine too. And autocomplete has disappeared and I could, everything is off.
Try restarting Xcode. I mean, I don't know.
Can you zip and put the project with changes into Slack if it's possible?
Yeah, I can. I mean, that means that you haven't.
I mean, I did type everything, but I have a lot of typos.
Yeah, okay.
Because
Hang on. iOS3. I actually have to go. I've got a meeting I have to get to, and I have to drive like half an hour to get there. So I hate to just be like, "Hey guys, see ya." But I just uploaded my version, which is working. And I will be back this afternoon to go through any questions you might have. You are going to be using Fetch Results. Basically, you're going to update the journal app that you built yesterday to use Fetch Results Controller instead of doing things the kind of dumb way. But yeah, I'll be back to support you with that, and I will get this recording posted as quickly as I can. So I will see you in a couple hours.
Is anyone going to the company presentation?
I'm going to drop in, but I don't know if I'll stay the whole time.